Capacitors in parallel. Two capacitors at C1, C2 are connected in parallel. This is C1 and this is C2 connected in parallel. The current passing through the capacitor C1 be I1, current passing through the capacitor C2 be I2. That voltage across capacitor C1 be VC1, and that voltage across capacitor C2 be VC2. The total current passing through this combination is I. The equivalent of these two capacitors connected in parallel is C equivalent. The current passing through this is I, and voltage across this is VC. We know that current passing through the capacitor, the expression for current passing through the capacitor, I is equal to C into dV by dt. With this expression, current passing through this equivalent is I is equal to C equivalent dVc by dt. Here this is expression 1. Similarly, current passing through the capacitor as C1, it is I1 is equal to C1 dVc1 by dt, that is voltage across C1 is Vc. Similarly, current passing through the capacitor C2 is I2. I2 is equal to C2 into dVc2 by dt, that this is 2. But in parallel circuit, voltage is same, that is total voltage or applied voltage is same as that of the voltage across the input elements in parallel circuit. That is, voltage across capacitor C1 VC1 is equal to voltage across capacitor C2 VC2 is equal to total voltage or applied voltage across the combination, that is Vc. And we know that total current in the circuit, parallel circuit, is equal to the sum of the individual currents passing through the elements. It is total current I is equal to the I1 plus I2. In parallel circuit, voltage is same, current divides, and the total current is equal to the sum of the individual currents passing through the elements. Now substitute these three in this expression. As in place of I, we write C equivalent into dVc by dt equal to I1. In place of I1, we write C1 dVc1. What is Vc1? Yes, Vc. In parallel circuit, voltage is same, dVc by dt. Yes, I2 is C2 into dVc2 by dt. Vc2 is Vc dt. Then C equivalent dVc dt is equal to C1 plus C2 dVc by dt. Take it as common, used to get cancelled. Then C equivalent is equal to C1 plus C2. From this expression, if two capacitors are connected in parallel in the sense equivalent capacitance value is equal to sum of the individual capacitance values. For n number of capacitors connected in parallel, C equivalent is equal to C1 plus C2 plus and so on plus Cn.